All right, we're going to do a few problems here on page 386. Starting with number 6, the directions in the book say, are the triangles similar? If so, write the similarity statement and name the postulate or theorem you used. If not, explain why they are not similar. Well, first of all, ways that triangles can be similar are angle-angle similarity, side-angle-side similarity, or side-side-side similarity, or they're just not similar. And then you got to recognize the fact that there are two triangles here. It looks like there's only one, but you got to recognize the fact that there is the small one near the top. That's a 20 by 25, and then the bigger one here, the all-encompassing. And they want to know, are these two triangles similar? Now this side length here, you've got to go 20 plus 25, what is that, 45? And 25 plus 30, that's 55. Well, in order to be similar, they've got to have two angles that are equal. Right now, they both for sure share the top angle. I don't know if this angle here is equal to this angle here because I don't know if the lines are parallel. So we can't assume angle-angle right now. Maybe side, angle, side, side, angle, side. Maybe it's this one, side, angle, side. And the way you would try to test it out is see if they're in the same proportion. 20 on the left to 45. I'm putting an equal sign here, but really I'm trying to figure out, is it equal to 25 on the right to 55? And we're just going to need to reduce that, and if the two fractions are the same result, then you would say they're equal proportion, that the left side is growing at the same rate as the right side. If you have a calculator such as this, there's a button that can reduce it for you. You would just go 20, there's this ABC button here. Then you have, the calculator will show this, which is a fraction key, then 45, then hit equal sign. And so this is 4/9. Now, is that the same as 25 over 55? Well, 25 ABC, 55, and that is 5/11. So obviously these are not the same. So these are not similar because the proportions are not the same, because 4/9 is not the same as 5/11. They are not growing at the same rate. If you didn't have this ABC button, you could simply just go 20 divided by 45. It'll turn it into a decimal, 0.44444. Remember that number. 25 divided by 55, just use the division bar, 0.454545. So that's slightly different. And that slight difference is why it is not similar. Okay, I'm going to do 21 here on page 387. I just photocopied the book here. There was a little newspaper article here to the left about skyscraper 9. This must be German. Yeah, it's Germany. There's this lady that's complaining that there's a skyscraper built near her apartment. She's basically, the skyscraper is huge. Skyscraper is 265 meters tall. She's obviously worried about a shadow going into her apartment. Well, here's the question now. Indirect measurement. Suppose Mrs. Klaus is 1.75 meters tall. So here's Mrs. Klaus, and she has a shadow. Now she is 1.75 meters, and the shadow is 1 meter long. How long would the shadow of the proposed building be? Well, there's a building here, and this building is 265 meters high. So the question is, how long is this shadow here? And that will be X. Now you got to imagine there's a sun out here, and when the sun shoots its ray on a person, it will create the shadow. And this is pretty much two triangles here. This triangle is a 1.75 by a 1. This is 265 by X. What we're basically going to do is, again, focus in on these two triangles here. Here's one, I'm just highlighting it in red, and here's the other one, I'm highlighting it in red. And so what we're going to do is 1.75, the person to the shadow, is equal to the building to its shadow X. And then you would cross multiply this and solve for X. So 1.75X is equal to 265. So x is 265 divided by 1.75. It would be 151.4 meters long.